All right, this section is going to be reviewing, or this recording is going to be reviewing section 4.4, the zeros of polynomial function. So in the last section, 4.3, we dealt with finding the synthetic division, and we use synthetic division and things like that to find zeros, or at least we attempted to, factor out things. Well, that's basically what we're doing here, okay? If we take a look at this, what we're doing is we're trying to find the possibilities of zeros, and then we're going to extract them out. So the first question that's here reads, consider the following polynomial, and they give you the setup of synthetic division, right? So they said the result of this above synthetic division provides that because the remainder is 0, that -3 is in fact a 0. All right, and then based on the above result, a p can be factored out as, and this is the thing you need to remember, is that a factor, or a 0, where x is equal to -3, that's 0. The factored form of that is just bringing the -3 back over and making it become x plus 3. So that's what we're looking for the factor. And that factor, then the result of the polynomial has it where the value of -3x squared, and then you don't have any middle term there, and then you have plus 3 is the remaining value system, or the polynomial that's left over. So that's comes from here. Now, when you're looking at finding the possibilities of zeros, these guys, we go ahead and use the rational zero theorem. And what we do is we find the factors of the constant, and factors are the constant is one, being that is 21, is 1, 3, 7, and 21. Now, the thing is that whenever you're finding factors, all right, and you're talking about the possibilities, and by the way, it's the factors of the constant over the factors of the leading coefficient, which is right in front of the highest degree power, in this case being 1. Now, whenever you have possibilities, you have the possibility of this. If it, for example, was a positive value system, then it would be negative divided by negative, or positive divided by positive. So in order to account for all different possibilities, what we do is put a plus or minus in front of all these variations, and even in the so now once we're done with that, then when we go ahead and say, well, what is 1 divided by 1, 3 divided by 1, 7 divided by 1, and 21 divided by 1? Well, that would give us plus or minus 1, plus or minus 3, plus or minus 7, and plus or minus 21. Now, in this system, this is unacceptable. They want you to put it in as 1, 3, 7, 21, as well as -1, -3, -7, and -21. So that's how they want you to put it into the system. All right. So they're just saying put the positives and the negatives. Now you can put it in any order you want. It doesn't make a difference. Now you can practice that with this as well. If you look at this one, we would have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And that would be the factors of the constant over the factors of the leading coefficient, which in this case is 7, so it'd be 1 and 7, plus or minus. All right. Now, what you end up doing is you take 1, 2, 3, and 6, and you divide it by 1 as well as you divide it by 7. And when you do, you get plus or minus. And by the way, it's plus or minus, but remember you have to put it in order like that. And I'm not doing that anymore. I did it once for you just to show you that that's what you need to do, but I'm not going to do it anymore. So plus or minus 2, plus or minus 3, plus or minus 6. Then you got to take the 7 and divide it. So 1 divided by 7 is plus or minus 1/7. 2 is plus or minus 2/7. And then plus or minus 3 is 3/7. And then plus or minus 6/7. So that would be all the possibilities. Now, once you develop or you figure out what your rational zeros are, all right, then you use synthetic division to determine what are the actual zeros. That's what the next question is reading here. So, and by the way, you have to be in order from least to greatest in order for it to do this. So this one you have to put first in order from least to greatest. So it's going to be x to the cubic power, x cubed, and then -4x squared plus x plus 6. And then you proceed to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And since it's all over 1, it's understood 1, these are our possibilities. All right. Now, what you do, if you did it old school, is you go ahead and take 1, all right, and then you divide it into the leading coefficients, which is 1, -4, +1, and then +6. All right. And then you go ahead and see if it works. You drop 1, multiply, add, multiply, add, multiply, and it doesn't equal a 0. So you throw it away. Then you move on to -1. You erase all this. Well, that 1 you can leave. But you erase these, and then you go ahead and see if the next one works. All right, 1, -1, and this would be -5. Go ahead and put that. That'd be +5. Add that together. That'd be 6. Go ahead and multiply, and it gives you a 0. All right. So now we have a 0. So that means you can factor out. That means you can factor out a x plus 1, and because the 0 is -1, that leaves us with then x squared minus 5x plus 6. And then we can ask ourselves, well, what two numbers multiply together to create +6 add up to -5? And we think 2 and 3, right? So we go ahead and do that, and we get -2 and -3. All right. Now that means the zeros are -1, +2, +3. All right. And if we look at this, now watch this. This is the answer that we put down here, but I put it as plus or minus. And then, of course, then you have -1, 2, and 3. Now, that is not the easiest way. Imagine this. If you go ahead and start using the graphing calculator proficiently, okay, being that this is what it looks, this seems like it's the number that I'm looking for, or the equation I'm looking for. If you put it into the system like this, right, and you go ahead and hit second graph, look at -1 is 0, 2 is 0, and 3 is 0. See, we look at the end result, right? Those are all zeros, and the output is equal to 0. So now you could have done this on the graphing calculator within seconds. All right. Now the point of this is that, matter of fact, I'm not going to choose to do it this way again, unless I absolutely have to. But you want to make sure that you know how to do it and what you're trying to do. Okay. So then this is doing the same thing. You got to find the factors of the constant over the factors of the leading coefficient, find the possibilities, and here they would be. Okay. And then you use synthetic division or other various methods So you can use your graphic calculator to determine it. All right. And so if you take your calculator, you punch that in. So I'm punching it all in right now. Okay, I'm glad I looked at that. This is supposed to be 3 here, because it's the 3x squared, right? And you have the negative 25x, and then you have the plus 75. All right, so I've now punched it into my graphing calculator. All right, now I go ahead and hit second table, and I know now the value is going to be -5. That all I need is 3 zeros. So -5, 4, or 3, excuse me, and 5. So those are all the 3 zeros that I have. See, I found all the zeros by looking at them. I'm looking for them. So I'm looking for -5, 3, and 5. All right, and there it is. Okay. I apologize about my dog. He's excited. He wants to go outside. And my wife doesn't want to bring him out. It's too hot outside. Oh, geez, Patches, please stop talking. He likes talking. All right. Okay, so the point of all that is I showed you that you can use your graphic calculator as a means of getting to these answers. Okay, so I'm going to let you take and handle this now. The rational zero theorem isn't that complicated to get through. Okay, now this I'm going to take my time with, because you can make mistakes on this. All right, and you want to be careful that you don't make mistakes. All right, now the way that this works, okay, is it tells you how many roots you have. All right, it tells you that there's 3 roots because the degree power. So now the way you set this up is like p of x, all right, equals, we have a constant. This is a setup. Like this way you set this up, that variable can change to any letter. It doesn't matter about p. But then you want to go ahead and find your roots. All right, and your roots are your factors, right? So you have 8 is one of your roots. So then the factor is going to be x minus 8. But it says a multiplicity of 2, so we're going to put 2 in here. Then we have -9 as a root. So that means we have positive 9 as a factor. Okay. Now it gives us additional information there. It says that p of 2 is equal to -792. We have to work on that after we're done simplifying this a little bit. We have to do the distributive property and such things as that. So let's take a look at that. Okay, so doing the foiling method, or recognizing this is a perfect square, we were going to get x squared minus 16x plus 64. All right, and then we got to go ahead and multiply that against x plus 9. And so doing that, we get the following, foiling it out a little bit, or doing this distributive property, we get right. So all I did was distribute the 9 to everything, or excuse me, the x. Now I'm going to distribute the 9. Now I'm looking like I'm going to fall off the page here. All right. Now it's 9 times 16, and that's a negative value. And last but not least, we have 64 times 9. Yep, and it's positive. All right, so I fell off the page. I hate doing that. All right, so right now I'm going to clean it up by bringing like terms together. So now I have x to the third 16 and this 9 come together. Okay, so we're going to go ahead and bring that together as negative 7x squared. And then this 64 and this 144 also come together, and that'll give us negative 80. And then we have the plus 576. Now, this is where we're a little bit stuck, all right, because we can't do anything further. So what we do is now implement the P of 2, and then we want to go ahead and make this equal to negative 792. So what this means is I'm going to insert the 2 in every single component of wherever I see an X, and I'm going to change all of this, all right, into negative 792. So what I'm going to do is I'm not going to write it this way on this line, because I'm going to say that this is kind of what we want to leave alone for a second, but I'm going to go ahead and to make this negative 792 and leave A alone, and then go ahead and put 2 in for everything. So 2 to the third power is 8, and then I'm going to go ahead and have 2 times 2 is 4, 4 times 7 and then I'm going to have 2 times this is going to give us negative 60, and I'm going to have 576. Now I'm going to take the calculator. I'm going to go ahead and punch it in. All right, and then we're going to go ahead and do. Just making sure I got it all right. That's that. Okay. I got to make sure all my signs are right. It's easy to get tripped up here. Okay, that looks good. That looks good. That looks good. Okay, I'll just double check things. All right, and then we have this. I'm double checking. See, it's always good to double check, and you got to be careful with things. And that's what I want to see. So, okay, so then you have this. So you're using your calculator a lot in this. Be patient and don't rush it because it's so easy to make mistakes. I've made enough of my own. So now you get A. A is equal to 2. Now, the reason why I didn't want to disturb this line up here when I was doing this is because I want to actually put 2 in here mentally and distribute it in my mind. So my answer is going to be P of X is equal to 2 times X. And by the way, this is actually negative. I got to make sure I remember that, right? So this is negative X cubed, and this is positive 14x squared, because all I'm doing is distributing out the negative 2 to everything, right? And this is going to be positive 160, and this is going to be negative, and then I'm going to take 576 times 2, and then get negative 1152. All right, let's see if we got that one right. All right, looks like we got it right. And like I said, this was a bear. This is not an easy problem, okay? You got to take your time with it. And you might have to watch this a couple times in order to control the process. All right. Now I'm going to do one more with you, okay? With actually I'll do two more with you. I'll do one with just I and then one where I need a conjugate pair because that's nasty. Okay. It's hard when I say nasty, by the way. All right. Now, this is a fourth degree polynomial. All right. When it's the fourth degree polynomial, you have to realize that things come in conjugate pairs. All right. Conjugate pairs. So if I have this set up, then I'm looking at it like this. All right. You have to set them up like that. There's the 4 zeros that we're looking for. Now what you do is you fold these first, the ones with the conjugate pairs. So why? Because what you end up with is simple. It's x squared plus 1, x squared plus 64. And now you just do the foiling process. And then this gives us and now we take and put in the 3. All right. So we're going to go ahead and put 16, or excuse me, 1460 A, and then we're going to do 3 to the 4th power, right? That's 81. And then we're going to do 3 to the 2nd power times 65. Plus 64. And then we have A and 730. We're going to divide both sides by 730. All right, so 1460 divided by 730. And then we get 2. So A equals 2. And then what we're going to do is just drop it into this one right here. We're going to take away that X, right? And then we're going to go ahead and distribute the 2 in for every part. So take this A out and put a 2 here. And then if we distribute it out, we would get P of X equals 2x to the 4th plus, and it's going to be 130, all right, x squared, and then it's going to be plus 128. Okay, because we have to distribute it all the parts. So taking a look, we can see we got the same answer. All right, this is not easy. I'm not pretending it is, okay, but I did give you, the strategies for how you do it. Now there's one last one that I want to address, and that's number 13. Okay. Now this is a 3rd degree polynomial with a binomial and a 0 of negative 6. So when we are given 6 plus I, the conjugate pair is going to be 6 minus I. So this is one factor. All right. This is another factor, and this is, I say factor, but it's 0, and this is another 0. So these are the 3 zeros. Now, in order to go ahead and start solving that, we go ahead and put it into the equation of P of X times A. It's always A. And then it's going to be X plus 6. And then it's going to be X minus 6 plus I. And then it's going to be X minus 6 minus I. So there's the conjugate pair. So what we do is we remove the parentheses by foiling out the negative sign in all of it, in both of those binomials. So we're going to get the following. All right, and then we're going to go ahead and FOIL this out. So I say FOILing, but distributive property. So this times this gives us that, this times that. So I continue on, I go on throughout the process. And then, what I'm going to do is I'm going to slide this down. I don't want to run off the page if I don't. So I'm going to slide it down. Looks like I'm falling off the page anyway. It's so long. Okay. So it's this times this, this times that, this times that. And then I'm doing this times this. It's negative xi. It doesn't matter how we put it, but it's that negative xi. And then we have, okay, then that's positive 6i. And then we have, it'd be negative I squared, which is plus 1. So now I go ahead and combine like terms and simplify things. So now this one wipes out this one. This one right here wipes out this one right here. And this comes together with this, and this comes together with that. So you're going to end up with this. See, negative 6 minus 6 is negative 12. And then this plus this is that so far. Now we finally have that done. We need to multiply that against that x plus 6. Okay, so filling that out, you get x to the third minus 12x to the second plus 37x. All right, so I just distributed out that. Now I'm going to FOIL this out to everything. So I'm going to get plus 6x squared. This times this is going to give us negative 72x. And this times this is 222. Okay, so again, fell off the page almost. Now I need to combine like terms. So now I have x to the third. These two come together because it's negative 6x squared. These two come together, so it's going to be 72 minus 37 is going to give us negative 35. And then I have this one just by itself. All right. Now I'm done combining everything. Okay. Now I'm going to go ahead and finally take advantage of the fact that P of negative 3 is equal to that value there. So I'm going to go ahead and I'm going to plug that in. So I have negative 492 equals, and then it's going to be A times is negative 3 squared is going to be negative 27. Or it's not squared, it's cubed, excuse me. Then negative 3 squared is 9. 9 times 6 is negative 54. And then negative 3 times 35, all right, is negative times a negative is positive. Is positive 105. All right, and then we have plus 222. Now I'm going to take my calculator and add all that together. I'm going to get that this equals 246a, and that's positive. Okay, and then I have a negative 492. I'm going to divide both sides by 246. And so that leaves us with a is equal to 2. That's negative, by the way. Okay. Now I go ahead and come back up into here and replace it into that one. So you can do that mentally. So P of x is equal to negative 2x to the third, and it's negative 2 times that is 12x squared. And then negative times a negative is positive 70. And then negative 2 times that is going to give us negative 6. Oh, excuse me. It's 2, not 3. All right. And there we have our answer. And it looks good, which is always rewarding that you get it right at the end. That's a lot of work. Okay. I'm not saying, like I told you, I'm not saying this is easy. I mean, I've given you now a full process for how to do it, but there's a process and you got to get through it. So take it for what it's worth. All right. This will conclude the recording for level lesson 2-4.